Okay, hi folks. Thanks for joining us today. In today's webinar, we will be talking with Anyscale. To that end, here's the agenda for our talk today. We'll start with an introduction of the speakers and talk about how AWS is democratizing the AI revolution. Then we'll delve into our partnership with Anyscale. Then we'll go into Anyscale's hosted SaaS solution and the customer's VPC deployment option of the product. My colleague will then discuss how Anyscale can manage the infrastructure for AI ML, which allows you to keep costs in control. Then we'll show you a demo of the Anyscale hosted SaaS solution with a focus on cost management. And this is followed by a Q&A session and a call for action. During the webinar, if you have any questions, please post them in the chat session. We have other folks from Anyscale that will potentially respond to your questions right in the chat, or we can discuss those questions at the end in the QA session. To start with, my name is Art Siddiqui. I am the Partner Solutions Architect with AWS, and I work closely with the Anyscale team, focusing on GenAI and machine learning. Marwan, why don't you introduce yourself, please?
Hey folks, I'm Marwan, and I'm an AI engineer at Anyscale.
So I wanted to talk about some of our capabilities at AWS. At AWS, we are innovating on behalf of our customers to deliver the broadest and the deepest set of machine learning capabilities for builders of all levels of expertise. The goal here is to remove the undifferentiated heavy lifting so that our customers can move faster. Over the past 5 years, we've been investing in our own silicon to push the envelope on performance and price performance for demanding workloads like ML training and inference. Our AWS Trainium and AWS Inferentia chips offer the lowest cost for training models and running inference in the cloud. This ability to maximize performance and control costs is why leading AI startups such as Anyscale runs on AWS. As you start to think about the future when you need to train and deploy models at scale in your application across your organization, most costs will be associated with running these models and doing inference. The production application can constantly be generating predictions and potentially generating millions per hour. The Inferentia 2 instances deliver up to 4x higher throughput and up to 10x lower latency compared to the prior generations of Inferentia-based instances. These capabilities deliver up to 40% better inference price performance than other comparable Amazon EC2 instances and the lowest cost for inference in the cloud. In addition to silicon, AWS offers a broad range of ML frameworks and AI services. Expert practitioners can develop in the frameworks of their choice. Data scientists can use end-to-end capabilities of SageMaker. Business analysts can build their own models using Canvas, or application developers with no ML skills can add intelligence to their application using our pre-trained models offered as managed services. These are some of the services that I mentioned, but you can see it at the top of the stack. It's labeled the AWS AI services. The idea here is that at AWS, you can innovate faster with the most comprehensive set of AI ML services. Let's talk about our 4 key areas where AWS is helping deliver that set of innovation. First, AWS enables AI-powered use cases with hundreds of pre-built algorithms, models, solutions for common use cases and industries, and delivers these at a faster time to market with 23 pre-trained services like Amazon Personalize, Amazon Kindra, and Amazon Monitoring. Secondly, at AWS, we're working to democratize access to ML and make ML accessible to more people. With Amazon SageMaker Canvas, AWS empowers any business analyst to make predictions without writing any code. With our AWS AI service, you can easily add AI capabilities to your applications with little or no machine learning skills. Third, you can easily scale ML with AWS. Amazon SageMaker allows you to build, train, and deploy ML models for any use case. As we continue to see the exponential increase in sophistication of ML models with an increasing number of parameters, you can build your own or access open source foundational models on AWS through Amazon SageMaker. And last, we're committed to helping you grow your ML skills at your organization and educating the next generation of ML developers with a whole host of resources from AWS training to AWS Deep Racer to our AI and ML scholarship program and AWS Machine Learning University. You can also further accelerate your journey with AWS ML Embark and AWS ML Solutions Lab. Amazon has been investing in AI and using ML for the past 20 years as some of the most sophisticated ML deployments in production. We have helped more than 100,000 customers achieve ML success. And again, these are some of the reasons why Anyscale utilizes AWS for their platform. To that end, I wanted to take a moment and give a brief introductions to Anyscale. Anyscale platform is the managed version of the open source Ray product. This can be used to scale and manage distributed AI applications on AWS. AI takes the difficult task of infrastructure management of a distributed AI applications, and it allows Anyscale's customers to focus on the model and the application itself. To that end, Anyscale's platform has shown to reduce the cost of developing distributed AI applications and reduce the operational expenses of running those applications by as much as 50%. With that, I'd like to hand over to my colleague Marwan, who will review and demonstrate how you can optimize cost and performance for modern-day AI applications on AWS. Marwan, take it away.
Thank you for this nice introduction to Anyscale Art. Let me just share my screen. So hopefully you see my screen now.
Yes.
Like Art said, I will be doing a live demo of how you can deploy on Anyscale and with a focus on cost efficiency and scale. But before I do that, I'm going to take a closer look about how Anyscale is deployed on AWS. So this diagram is like a high-level architecture diagram of Anyscale. Admittedly, like there's a lot going on, so let's break it down for you. So Anyscale employs like a control plane, data plane architecture. So here on the right, I have my control plane, which is the zone that orchestrates the compute. And on the left is the data plane, which is the zone where the compute is running and where the data lives. So the core part of the data plane is the Ray clusters that are running on AWS EC2. And those EC2 instances will have access to a shared cluster storage that's running on EFS. And they will have access to like a Redis cache that's on a MemoryDB instance for high availability and fault tolerance. Additionally, they have access to external services like data that's sitting on S3, and they can execute images in the Elastic Container Registry. You'll notice that all of these are deployed on public subnets across different availability zones within a VPC. And so here, let's talk about two deployment models for Anyscale. The first model is the VPC is in your cloud, which we call it bring your own cloud deployment model. And there you have full control over your compute and your data, and you can bring in like any reserved capacity that you want. The other is like a fully SaaS solution. This option effectively means like zero infrastructure setup for you as a user, where the VPC will be inside Anyscale's cloud, and all you have to do is make use of Anyscale. So for any questions on this, please, you can post them in the Q&A, and I have my colleagues that can answer them, and we will pause later on for questions. So just a quick overview of the AI challenges of today's world. The two main challenges are basically cost and efficiency. So if we take a look at the large language models of today, both open source and closed source ones, and especially the closed source ones, the large language models, you can easily extrapolate using the USD per 1 million tokens that this will cost you on the order of hundreds of thousands of dollars to deploy these models on a given year. And not only is it expensive, but most of the organizations do a bad job of like deploying their models. Here I'm showing a survey conducted of 1,500 organizations, where we see that most organizations do a poor job of utilizing their GPUs. So only 51 to 70% of their GPUs is being utilized by 53% of the organizations. So today I'm going to discuss a specific generative AI use case. And that use case is that of deploying embedding models. So what are embedding models? Embedding models are models that can encode unstructured data. So like think of images, text, audio, into numerical vectors. And so why might we want to use them? Like it turns out that they're very useful for things like semantic search, where like, let's say you have a query, you can encode that query into a numeric vector, and then you can return like the semantically similar documents by computing a similarity score and fetching those retrieved documents. This same approach could be used with recommendation systems to find like similar items or users. And those retrieved documents could be passed to a large language model so that it can generate a response based on a knowledge base. We call this pattern retrieval augmented generation, or RAG for short. And the challenges here are that we want to run we want to meet some performance SLAs given dynamic traffic, but we want to run in a cost-efficient manner. So to achieve this, we're going to make use of RayServe, and we're going to deploy RayServe on Anyscale. So first, like, what is RayServe? RayServe is a easily scalable framework for serving ML applications. And it's easy because it's Python-based. And it's like a very nice abstraction that sits on top of Ray Core, which is the distributed computing platform. And it has rich integrations with commonly used Python libraries like FastAPI. And so like the way RayServe works is what I'm showing here in this diagram, where like you will package your model into a deployment, and it will run as multiple replicas. Those replicas can run on multiple nodes. And usually those replicas are controlled on a specific head node. So let's take a look at the first, like how you configure your RayServe application. So you can configure your RayServe application using something like YAML. So for anyone who's deployed to Kubernetes before, this is like a common pattern where you use YAML to configure your service. Here, what I'm showing is that you can start scaling from 0 and to 0. So let's just walk through this YAML file. This is my embedding service, and I'm configuring the embedding model deployment. And I'm saying that I want to start with an initial number of replicas of 0. So this means that when I deploy the service, I will only have my controller or my load balancer running, and I don't have any embedding model replicas running. So I don't use GPUs yet until the first request comes in. So that's when scaling will happen. And then if I want to scale back down to 0, I can set my minimum replicas to 0. The next thing that RayServe allows is for like fractional GPUs. So it turns out like these embedding models don't take up too much GPU memory to load. So in this case, like I want to run on an A10G accelerator, but I only want to use 1/10 of that A10G. So I can specify my num GPUs to be 0.1. And in this case, Ray is going to perform a logical accounting of the available compute. And so it will try to like schedule 9 other model replicas onto the same GPU, effectively maximizing the GPU utilization. And now when we deploy RayServe onto Anyscale, we can leverage a lot of cost optimizations thanks to our deep integration with AWS, specifically AWS EC2 Spot instances. So here what I'm showing is how I can set the compute configuration for my Anyscale service. So there's 2 parts to the RayServe. There's the head node, which will host the main controller, which you can think of as the load balancer. And then there's the worker nodes, where we'll be running our model, embedding model replicas. So in this case, I'm using an M5X large, like a CPU for my head node, and I'm using a G5X large, like a GPU instance for my worker nodes. And I'm also specifying that I want to scale from 0 nodes all the way up to 4. And down here is where I'm specifying my market type, and I'm setting it to prefer spot. So what this means is that Anyscale is going to go and try to find a spot instance for us. But if there's no capacity, then it will fall back to on-demand. But additionally, what this also means is that periodically, Anyscale is going to check for any spot instance availability. And in the case spot instances become available, Anyscale will safely migrate the replicas from on-demand back to spot. And what it also means is, like, if we're running on spot and we have to like evict because the spot is no longer available at the price that we took it at, then Anyscale will safely migrate back to an on-demand instance. And additionally, I should say, like, if you strictly want to run on spot, we can change this market type from prefer spot to just spot. There's many Anyscale cost and performance optimizations that's going to be enabled for me by default when I deploy on Anyscale. So here I'm going to take the time to talk about one, which is called Replica compaction. So usually, like when I'm deploying to an Anyscale service, I want to deploy multiple models. So like in our case, think of it like when I'm deploying my embedding model, I probably also want to add like a large language model to it for like a RAG application. In this diagram, which I took from our blog, we're showing that we're deploying 3 large language models. Model A, which is a 70 billion parameter model, B, 13 billion, and C. And so given the dynamic nature of the traffic, what ends up happening is we initially start with like a somewhat optimal setup where like we've bin packed these replicas onto 2 nodes to maximize utilization. But then like the model A will get scaled down to 0. Let's say like no requests come in for model A for a set period of time. So now like we're left in a situation where our nodes are severely underutilized. So what replica compaction does, it's like a periodic thing where like we will check the GPU utilization. And if Anyscale will start migrating these replicas from node 2 onto node 1. And once it's done, it will take down the second node and saving us the cost of an additional GPU instance. So I will switch now to like a live demo of all the features I've shown you so far. But just high level, this is what I'm going to demo for you. So we're going to deploy an embedding model. It's going to be the NLP or GTE large model. And this is implemented using Rayserve and Fast API. And we're deploying this on Anyscale services. And for context, you can think of this as like a component in an enterprise QA application where traffic is dynamic and practically 0 in after work hours. So I'm going to switch to my Anyscale workspace. And so basically an Anyscale workspace is you can think of this as like an IDE, like Visual Studio Code, where it's running against array cluster. So it's, and in this case, I'm going to start off with the same YAML file that I've been presenting to you guys. And here I'm just, for the sake of time, I'm going to show you how to like deploy this to Anyscale services. So I will run this command, Anyscale service deploy, and provide this YAML file as an option. And so this will start my service. In the meantime, let's just talk through this again. So what this is doing is it's configuring my embedding service, and it's importing the code from a main.py file, specifically the my app object. And the current deployment is an embedding model deployment, where here's my auto-scaling config, where I can set certain things like how many requests each replica should handle before I start scaling to the next replica. The minimum replicas, initial replicas, so like I can start scaling from 0 and scale down to 0. And the maximum number of replicas, so I don't keep scaling infinitely to control my costs. And any delays on scaling, upscaling, or downscaling. So this will really depend on the nature of your traffic. And additionally here, like the num GPUs is set to 0.1 because we want to use like fractional GPUs, and we only need 1/10 of an A10G. And here's where I'm showing my head node, where I'm running a CPU instance of an M5X large, and I'm running a GPU G5 2X large instance for my worker nodes. So let's take a look at the code, my main.py file. Here's some imports. I'm using Fast API. Sentence transform is to load the model, and Rayserve. So what I do is like you instantiate my Fast API instance. And here's where I define my serve deployment. So a serve deployment is usually a callable class where all of the expensive state is handled in the constructor. So in this case, we need to, like, when we launch our replica, the first thing we need to do is we need to go and load the model, load this embedding model, and place it on our CUDA device. And then the next thing is we specify like our endpoint. So like this is our encode endpoint where like we'll handle the HTTP request. So here we're getting a name and we're encoding it back into a vector, which is a list of floats. But one thing that I'm showing here is like dynamic request batching with RayServe. So instead of doing this one name at a time, I will dynamically batch up to like 10 names. And I will log that I'm starting my encoding. I will perform my encoding and return back the vectors. So now let's go take a look at my service. So the Anyscale service will show us like our deployment, which are embedding model deployment, and it will give us metrics and observability. So I'm going to go to the Ray dashboard and take a look at my RayServe application, and I can see like I only have a deployment model with 0 replicas right now. And on the right-hand side, I can take a look at my compute resources. And I can see that I only have a head node running right now with no worker nodes. So I'm not making use of any GPUs because I don't have any requests. And this is like when the deployment first started. So now I'm going to mimic like sending a request to my service. To do that, I will call my query.py file, and I will send in a single request. So now that I sent out this request, if I go back here, I will see that now all of a sudden I'm upscaling from 0 to 1 replicas. And if I go to my logs and I look at my service events, I will see that, oh, look, I'm upscaling from 0 to 1 deployment replicas for my embedding model, G5 2x large, and specifically in the US West 2A availability zone, and it's a spot instance type, and it just got launched. So here I'm showing that this dynamic nature of the autoscaling. And if I go back to my dashboard, I could see that my replica is starting. So what does that mean? For the replica to start, the node has to be available. And then once it starts, it needs to go and download the model, and then put the model on the GPU and then execute the request. So the first thing is that we'll see that the node is upscaling. And anytime now that we'll start seeing some logs coming through from the replica. So here I start seeing my logs. I'm initializing my replica and downloading my model. And now that I've downloaded the model, the tokenizer, some configs, everything's done. And then I finally handle my request. So now if I go back here, I should see that now I finally got back my embedding vector. So we can send more requests to this, but high level, this is the demo that I had in mind for you folks. So I will pause here and start looking at questions. Let's see. Okay. Vinayak asked, what if spot instances goes down? So what happens if a spot instance wants to like get preempted? This will send a preemption notice, and then Anyscale will spin up a replica on an on-demand instance, and now the traffic will start going to that on-demand instance. I noticed benchmarks missing for OpenAI. There's a cost analysis for it. Okay, I'm not exactly sure what you mean by that. We have some cost analysis and benchmarks on the Anyscale blog. I'd encourage you to go check those out. Do we support observability and model performance? Yeah, maybe this is a section I should showcase here. Is like if you go to your metrics, you'll start seeing integrations with things like Grafana for observability. In this case, you could see things like your QPS, your error QPS, and you can get further like hardware utilization metrics that I could also show in here. Things like how many nodes do I have running, how many ongoing requests. And if I go back to my Ray dashboard, I also get further metrics. So I could see my GPU memory usage right now. There's still only running one replica, and this sort of shows the fractional usage of our GPU, that we're not really using all of the GPU memory, that we could add more and more replicas to this. What is included in Ray open source versus the Anyscale service? So the Anyscale service will give you certain high availability features. And what that means is like like certain like ways of like production deployment. So like let's say you want to do a canary rollout, then like you've updated, you have a new embedding model now, and you want to go and deploy that. You could roll this out as a canary and switch a certain part of the traffic to that new model deployment. And then only once you've done testing can you switch all the traffic to that new deployment. So you could do those things easily with Anyscale services, versus with Ray open source, you will have to go and figure out those deployments on your own. And then you get versioning. So these are all of the versions that I've deployed here. You could easily roll back to a previous version. And so you get a lot of these production quality features with Anyscale. Can you use something like Keda for Kestra for building offline batch jobs using Ray plus Anyscale? Not exactly sure, but basically you should be able to integrate like with Ray. If you can integrate that code with Ray, then you can run this on Anyscale jobs. We did not showcase jobs as part of this demo, but Anyscale does offer you the ability to run batch jobs and get certain things like alerting for your jobs and automatic retries. What about monitoring performance on test data? So yeah, I maybe by performance, like if you mean running evaluations on for your model, then you can run these as like batch jobs and integrate with any of your favorite like experiment tracking tools or performance tracking tools. How's RayServe help support to deploy the models on custom inferencing server runtimes? So we can, if you want to use any custom inference library, for instance, like anything like VLLM or Triton, you could easily like integrate that with RayServe. And as a matter of fact, we've done that extensively on Anyscale. So you basically, the code that I showed you guys would just change to make use of your favorite inferencing library for large language models, let's say. I'm seeing all this execution Anyscale. Can I do this in AWS? Because we don't have partnership Anyscale as of now. So to clarify, this is running in AWS and this is running in an AWS cloud. So I'm running in US West 2. So this will be, if you want to make use of your AWS cloud and compute, you can with our deployment model. This is just giving you the GUI, the Anyscale GUI on top with like optimized Ray features for you to run your Ray code. Yeah, you will need to have an Anyscale account, but we can help you get started if you want. Thank you so much for these questions. We can keep going a little bit. References for running offline Ray jobs and its integration pattern. Yeah, maybe one of the panelists can share some references for running jobs. So how about Ray jobs for both batch and streaming? I'm not seeing much talks for streaming. So with Ray offers a library called Ray Data that enables you to do streaming. It's actually streaming execution by default, and you can connect it to any of your favorite streaming setups and execute jobs using that. I can deploy Anyscale into my VPC, similar to the Databricks deployment model, VPC peering my data plane to your Anyscale control plane. Yes, exactly, Chris. That's you got that exactly right. Unfortunately, I don't have a Ray data example ready, but we have plenty of examples as either as templates, like immediately when you are when you get to the I can show you that when you immediately get here, you can get a template for like running batch inference with LLMs for running batch jobs on Anyscale. And this is like a ready template where you can just launch it. You'll have the code and you can choose any of your LLMs and generate data like in batch. Okay, how's Ray serve? Okay, I think we know we've answered this. I think if there are no more questions, we can begin to wrap. Okay, thank you so much, everyone. I hope this demo was insightful for you to showcase how to make use of Anyscale and AWS for achieving scaling and cost efficiency, and hope to see you in future webinars.
Thank you, everyone.
Bye, guys.